our biggest issue over the next 100 years in Austin and for Texas will be water. I don't give a darn what the politicians tell you. The biggest issue will be water in this state. And we cannot sustain the population growth that we're seeing when we have to go through these periods of drought. And with changing climate and shifting climate patterns, again, it just doesn't take much to bring that semi-arid or that arid air to the west, eastward into our area.
I'm pleased to be joined today by Troy Kimmel, a long-time meteorologist, retired, worked for how many years, Troy, at KVUE here in Austin?
At KVUE for about 9 or 10 years, at Fox for a few years, and at CBS Austin for a few years, and ended the TV career in 2012, Lee. But glad to be with you as well.
Well, thank you very much for your time. Yeah, just before we get started here, could you tell people a little more about your background, your education? I know that you taught at UT as well, University of Texas, and I had the pleasure of actually taking your meteorology course, but maybe just a little bit of your life story.
Well, born in Northeast Texas, and after a little stint, which is important to me, that I grew up part of my life up in Northeast Mississippi. Came back and graduated San Marcos High School from there, then back over to Texas A&M, where I got my degree in geography and spent time up in meteorology as well. And then in 1984, was hired by KVUE to come over here and do weather. I was actually doing weather during my entire undergraduate career at Texas A&M over at KBTX TV over in Bryan College Station. But was hired over here in Austin, came over in April of '84. In 1993, I decided to leave KVUE for LCRA. LCRA was at the time, we just come off the big floods of 91, 92. They had the hydrologist and had people over there, but they were looking to establish a chief meteorologist position over there. And they wanted me to do that, and I accepted that, so I left KVUE. Beginning in 2005, I actually was brought on board at UT into emergency management to support as far as meteorological support for emergency management. And so I've really transitioned into that area now and more into support for emergency management. I really love that. As I get older, it still excites me. So that's what I'm doing now.
Well, let's dive right in here to our discussion. And, living here in Central Texas, we have good weather, but sometimes we make the news for the wrong reasons here. It's not California sunshine all year round. Can you describe a little bit where we are, obviously in Austin and kind of the hill country, about how we're, from my perspective, dominated by, Gulf flows part of the year and then northern air through, a good part of the winter. And how does that all set up and affect what we experience here?
It's a great question. And it has, Lee, everything to do with location. And I think it's so important for everyone to realize that we're at about 30 degrees north latitude. And that is a unique position, especially in the United States, just because we have access to tremendous amounts. Wouldn't be able to tell it lately, but we have access to plenty of amounts of tropical moisture off the Gulf of Mexico. And that feeds north. We're usually the first to get that as it makes its way up to the central part of the United States. But we're also close enough out to the west that we're close to that interior part, particularly between the Sierra Madres of northern Mexico, between the eastern and western Sierra Madres, that it's a very dry region out there. And then you run the southwest U.S., which is largely desert or what we call arid environment, or semi-arid when you get into West Texas. So it doesn't take much to move that air into place around here. And this is one of the things that I think has been so important when you consider whether you believe in what you think about climate change. Climate has always changed. Climate has always changed through the ages. The one thing that concerns us is that of late, we are seeing a little more warming than what we would expect. And Dr. John Nielsen Gammon, our state climatologist at Texas A&M University, points out it doesn't take much with weather pattern shifts that may be associated with climate change for us all of a sudden to be stuck with a much more arid type of environment. And that's where we've been lately around here. We're in drought in the state of Texas. In the last few years, we've had more and more of that. As what, Lee? The state grows. We have had people coming in from all over the country. It's honestly, to me, it's unsustainable. I mean, our biggest issue over the next 100 years in Austin and for Texas will be water. I don't give a darn what the politicians tell you. The biggest issue will be water in this state. And we cannot sustain the population growth that we're seeing when we have to go through these periods of drought. And with changing climate and shifting climate patterns, again, it just doesn't take much to bring that semi-arid or that arid air to the west, eastward into our area. If I don't do anything in Texas and talk to people around Austin, I say, go. And I know it's a long drive, but it's real important for people to do. You need to go over to Beaumont, and where, by the way, mosquitoes require flight plans. Okay, I'm serious. It's very humid, and they're over there. And get on I-10 and drive west to El Paso. And I want you to see the environment. I want you to really pay attention to the roadside and I want you to pay attention to the road, but I want you to pay attention to the environment. It tells the whole story. You get into Austin, you begin to notice the trees begin to thin out. You get in the hill country, you notice it becomes more and more vegetation that'll stick you or stab you. And things like this. And you get into West Texas, where it is truly more of a desert environment, far West Texas. This is what way Texas is made up. And if you can't make that road trip, then consider this. Beaumont sees about 55 inches of rain a year. El Paso sees about 10 inches of rain a year. That tells a story.
Well, thank you for that. Actually, that's a perfect segue because to people that aren't familiar with that, we seem to have obviously more, and we're going to get into the flood discussion in a minute here, but more rainfall, more flooding, and even in the hill country, typically in the eastern part, whereas you get over by the Devil's River, by Del Rio over there, it's much drier. They don't have as many. They do have some. And again, I guess that's because that drier air, right? And they don't have as much Gulf flows.
And we leave off the most important point to that, and we have to go start talking about physical geography now. As you move westward, the soils, look at those soils to the east of Austin. They're more of a rich soil. As you get westward, that soil begins to deteriorate, frankly, as far as its richness is concerned. And then you get into the hill country, and the 3 inches of maybe 1, 2, 3 inches of soil that you see are underlain by limestone subsoil layers. And then you throw the hills into all of that. And so we go from what we saw before the 4th of July this last year in 2025. And all of a sudden you drop 10, 15, 20 inches of rain overnight in an area. Where's that water going to go? At least in East Texas, Lee, it has a chance to soak in. You get over the hill country, number one, it's going to soak in through 1, 2, 3 inches of soil if you're lucky. It hits subsoil limestone layers, begins to run. And what is it running on? It's running off hills. And it goes into those beautiful low water crossings that we all love. And we go out in the hill country and just, they're beautiful places. They're photogenic, and they will kill you if you're not careful in a flash flood. And that's our biggest problem, is that we live in flash flood alley and these things come together. Then we also have to consider urbanization, especially of the I-35 corridor. What does that do? Well, the Best Buy parking lot over there, I never have understood, the fact that people think that's going to absorb any water. It's all going to run off there. So, these big events that come up and take us from drought, extreme drought, into flooding overnight, people just have to understand that. And that's why the National Weather Service, our Texas Division of Emergency Management, our state level emergency management folks are trying to get people to understand, in a sense, turn around, don't drown, to understand that if you think you're going to do well against a stream of water that's 6 feet deep in your car through a low water crossing in the hill country, you might ought to sit down with a funeral director and make some plans, because you're not going to get through that. And if nothing else proves that, the 130 deaths that we saw in Kerrville on the morning of the 4th of July is absolutely a testament to that.
Well, let's talk about that a little bit. And one thing, I appreciate you bringing all those factors into play, because I think obviously there's the climatic factor, the Gulf air, and then rises up over the Balcones
Right.
escarpment, and like you said, the geology, the hills, and the shallow soils. And then, of course, in Austin, and I heard you on another interview, and I remember that when I was a kid. My grandmother lived here, the Shoal Creek, some of the
Oh
bad
yeah.
floods, Lamar being underwater.
Yeah.
Um,
And
and so we had,
by the way, Lee, if you think that's the last time we're ever going to see a
of
problem
course,
in Shoal Creek, a
yeah.
lot of people here in Austin occasionally will tell me, well, we have retaining ponds now there in Northwest District Park. They're off of Shoal Creek Boulevard. Well, the only problem with that is I want you to show me the difference in urbanization and what areas we paved over since 1980. And I'm here to tell you, just because we have retention ponds up and down Shoal Creek does not mean that our issues are over with Shoal Creek. People up and down that creek have to understand that, and understand that this city changes every day as far as the amount of impervious cover is concerned. And are we paving over soil that at one time was able to at least accept some moisture to be able to soak into it? This is a big issue, and I hope Austinites understand.
Well, and along with that, I was reading some things. You remember that terrible hailstorm we had almost exactly 2 years ago, and the urbanization also. You can get some storms come in with the urban heat island, right? You can get some
Yep.
extra lift, and it was already a bad storm. Now
Yeah.
is a catastrophic storm. So
Right.
there's multiple impacts. And my day job being the executive director for Save Texas Streams, I'm glad you brought in about the water, because I think people just aren't familiar. They think, well, we get all this rain. Well, yes, it comes in batches, but then we can have long periods of, drought. And we had it in the 50s, and, back Oklahoma in the 30s, the whole
Yeah.
Dust Bowl, and, Grapes of Wrath, that whole scenario. And that's coming again. And so I think people assume it's one or the other, but it's really both. And
It's both, and the extremes go with it. And you brought up the 1950s, which is the one time where we actually saw Lake Travis go up over 50 feet in 24 hours because of one of these events. And it number one shows us what Lake Travis does, and frankly, what LCRA does as far as trying to regulate, I don't want to say regulate, but trying to maintain that river basin.
mitigate.
We don't want Austin washing away. And that was one of the reasons these dams were largely put up. And then we began to think, well, it's nice to have some water in these areas. Recreation's nice, but it's sort of a byproduct of all this. If you think that we can't go from drought to flood overnight again, I'll refer you back to July 4th.
Yeah, my dad remembers the 1935 flood here in Austin, which, and this had happened
Oh yeah.
before, inundated all of downtown, like up to 6th Street, I think.
Yeah.
And
And
so
that was the
I have
reason
a
that the
question
dams,
related
that was
to that.
actually the reason the dams were all put in at that
Right.
point in the 30s. Yeah, that the dams, they began to realize we can't have that much water coming down this river.
So we get these swings, and we've had, except for the floods, which again we'll get more in depth here in a second, but the last 2 summers we've had, by our normal standards, pretty nice summers, pretty
Yeah.
temperate and several degrees below average. But then we get these summers where, man, it is just hotter than Hades,
Yeah.
and we get, to me, it looks like this high pressure moves in from the west, the southwest, and it just sits on us. What causes that? Can you forecast that out because of El Nino, La Nina, or do we know why that happens some years, not others, and why it hangs
Well,
on so long?
but it happens, Lee, most every year, but it's a lot of the years are like the one we've just come out of, or the one before. It's not quite as bad. You talked about the high pressure. This is where we have to talk about the meteorology for a second. We normally will talk about when a cold front comes through. Cold fronts, or fronts themselves, are zones generally of lower pressure, and higher pressure will come in. Cooler high pressure at the ground will bring in cooler. When you get colder temperatures and it begins to really cool down this time of year, you can thank a surface high which is built up in the atmosphere. And that's usually a dome of cold air that's come down through the plain states. What causes this drought that we see in the summer is not high pressure at the surface necessarily, it's high pressure aloft. And first of all, please understand that pressure always decreases with height. So I'm not talking about the pressure is higher up there than it is at the surface, because that's not going to happen. But it's higher pressure aloft than you would normally expect to see. It's not cool. It's not falling as rapidly. The pressure's not. And this upper level high pressure, Lee, is nothing more than putting a lid on the atmosphere. When you get these upper level high pressure areas built in, just think about it. Don't do this, by the way, but think about it. We essentially glue the lid on the pot on the stove, and we glue the lid down. And you don't want to do that on the stove. And in the atmosphere, it just traps everything below. Our atmosphere can give a little bit, but this is what creates these very, very hot summers, dry summers that we see in a lot of cases. We're always going to see the what we call the subtropical high, or this upper level high above the area. It's pretty normal to see that during the summer. The key is, Lee, what's the intensity of that upper level high? And one thing that was interesting the last couple of days here in November of 2025 is that we noticed, even in the last few weeks, some fairly record high upper level high pressure records, even in the southern plains. And that was when we got our warmest last week and this week. So again, this is just what happens when these domes build up. It puts a lid on the atmosphere. You don't get, and by the way, triggering things to push things up. You don't get fronts during the summer, so you don't have that coming in here. And the high is basically the king. And when it becomes very strong, we run into very high temperatures, and what is around here the last few summers, we saw one about 3 years ago, to me was the most miserable summer that I ever remember. I made a habit of staying inside.
Is there a reason they hang around for so long some years and not others, or higher intensity? Do we understand that yet?
Well, we understand it as part of the upper level wind flow. And with that high becoming established here, it's hard to get waves that build south from the Arctic that are able to transport any colder air. And the high is hard to get rid of at the end of the season. There are a couple of things that we look at that can break up that upper level high. I kind of wonder sometimes if we have to get these to break up that pattern. And we've begun to see that now in the fall of 2025. The hurricanes are good at that. I'm just not sure that that's the price we want to pay, especially when you talk about a Category 5 moving through Jamaica. And in a way, it kind of changed, that system kind of changed the pattern a little bit, even around Texas.
But with your knowledge, you can't 6 months out or 3 months out go, well, this year, boy, we're going to have high pressure for 2 months. It's going to be an intense summer.
We can look at correlations with the Southern Oscillation, with El Nino and La Nina patterns out in the Pacific. Yes, there are things that we can look at. And folks that are in the business that I'm not in more of climate studies, and I look out 7 days. I consider myself lucky if I can do that. But these people look out, to 8 to 14 days, 2 to 4 weeks, and even monthly and seasonal outlooks. They will go look at the state of the Southern Oscillation, El Nino, La Nina. They'll look at other oscillations, the Pacific Decadal Oscillation, which is over the Pacific. We have the North Atlantic. There are all kinds of oscillations that they're going to go look at for these longer term outlooks. Not so much something that I look at on a daily basis, trying to figure out what the forecast is for Austin.
Another interesting aspect of that, just really quickly, is, and this is just, people, I think it's very important to have a basic understanding of meteorology, even if you have an app on your phone or whatever, anytime you're doing something outdoor, and we'll discuss some more of that in a bit here. But one of the things that I'm always interested in, you'll hear people tell us like, wow, it's so hot, it's hotter than normal right now. And, I'll look at it, or you can just feel it sometimes, you go, yeah, but it's really dry. And they don't understand this idea of the energy load.
Right.
If you have more moisture, the temperature is not going to be as hot because the water's absorbed a lot of that. Can you speak to that a little bit?
Yeah, and this goes back to the whole thing of the heat index that you hear about. Basically, you know, just looking at human effects of weather. We're trying to transition more into the wet bulb globe index, which is more of a good thing to use. But I think we're a while away from getting the public to understand that. So we deal with the heat index. This is what tends to kill people. I mean, you get more people that die when the temperature is 92, 93 with a high humidity than you do when it's 105 in Phoenix and the humidity's 15%. And as we get older, as we grow older, our bodies are more, and people with underlying medical issues, this is much more of an issue. The number one killer worldwide, Lee, is heat. And I know it sounds sexy to say tornadoes and hurricanes and lightning and all this stuff. Those are all hazards we deal with. But if you want to go see the highest numbers on an annual basis worldwide, you're going to go and look at heat. It's not something that I think we appreciate as much as we should. And that humidity factor is so important in that.
Yeah, I'll take, up to a point anyway, I'll take dry air over really humid air.
Yeah, yeah, absolutely, absolutely.
Yeah. Okay, well, let's go in a little more depth here on the July 4th flood. So I grew up in Kerrville and seen some bad floods before, but reading the hydrological report, they're now saying that at least on the South Fork of the Guadalupe River, that was a 1 in 1,000 year event.
Yep.
You know, about 13 inches of rain in about 3 hours. Just unbelievable amount of rainfall. Still, I think.
But Lee, at the same time, have we seen that before?
Yes.
Okay. And
yes.
And that's where I want to get to, because we're making advances in meteorology, but I'm going to tell you that I'm not sure that helps us much when we have to sit there and confront the fact that we lost 130 people that lived on this planet with us in that event. So this has happened before.
I've seen, this is the third or fourth one I've seen in my lifetime.
Yeah, absolutely. And what that comes down to, Lee, is this. Our weather forecasters perfect? No. I will tell you, I'm not going to give you any names, but I will tell you that I know the person that hit that flash flood warning button after the 1 o'clock hour on that Friday, the 4th of July. And I know he tried to reach out to people. He could not find people to reach out to, and things like that. We have got to, Lee, and you do this so well, but we've got to somehow take what you do in educating the public. We've got to bring this back to personal responsibility and weather safety and having a plan. Too many people do not have a plan. Notice I'm not even saying weather plan, Lee. I say a plan. What about if you're in the house with your partner, your wife, your husband, your kids, your parents? You're in the house in the middle of the night and the house catches on fire at 2 a.m. That ain't the time to be making a plan. You have to have a plan ahead of time. And that same plan, emergency action plan on a family basis, on a business basis, that must be done in advance. And we saw it in July, and I'll say this one time and I'll let it go, I promise. Don't blame the weather forecasters for that, for what happened in July. Are we perfect? No. But I'm going to tell you, we have to have a plan, and it's obvious there were weaknesses in having a plan.
Let's start with that. So in terms of educating people, and we'll get into some more details.
Yeah.
Why and correct me if I'm wrong, but I think that whole thing was set up initially there was a remnant tropical system which came in. Why are those things so dangerous? I know you have really saturated air, and looking back at the records, almost all of these huge floods around Kerr County anyway, have happened mostly in this July timeframe, 1 or 2 in early August. So what makes these so dangerous, and why do they happen then?
Well, and I'm not knocking on you, but I want you to consider, has it happened before that we've seen flash floods with tropical systems? Okay.
Yes.
So I'm going to pull back. By the way, was it especially well forecast? This event, the July 4th event, was it well forecast 4 or 5 days out? No, because we had this little remnant circulation, a little system out in the Western Gulf, and that thing, as you well know, Lee, was headed into the eastern Sierra Madre of Mexico, and the Sierra Madre is very intolerant of tropical systems. It'll dismantle and disassemble them really, really
I've
quickly.
run some programs out there. They stop right there.
Yeah, they stop. That's the last you see. Guess what? This one didn't. The remnant circulation snuck up into northeastern Mexico and then came across the Rio Grande into areas around Del Rio and west of there. And that remnant circulation hung around for days. Something that we all think about the Kerrville event on the 4th. I want you to consider what happened in Northwest Austin. On the night of the 4th and the 5th, we went through another wave, and it was a remnant circulation that may not have been that one, but as a result of that system. And when these systems come ashore from the Gulf of Mexico, they're coming from where? Maritime, tropical, rich atmosphere down there. So there's abundant amounts of moisture. So the forecast wasn't perfect. But when you issue a flash flood watch, and the National Weather Service Austin San Antonio did, at 1 o'clock on the 3rd, that Thursday afternoon, they issue a flash flood watch. What does this mean, Lee? It means you kick your plan in. Yeah. They mentioned the possibility of 4 to 8 inches of rain. Was it underdone? Yeah, it was underdone. But I got news for you. 4 to 8 inches of rain over the hill country is not good news if it happens all at once.
No.
And so it doesn't matter. So I have people say, well, it was 15 to 20. I don't care. I'm telling you, you should have caught that 8-inch and said, this is not going to be good. And we should have gone from there.
And do you think it's fair to say, and the way I look at it, I've got a friend retired from TCQ, and he was in the water department there.
Yeah.
And he says, anytime you have this really saturated warm air that time of year, you should be on guard, because any kind of disturbance can set it off. And I know in this case, this is beyond my pay grade, but reading up on it, what do they call it? The MCV, mesoscale convection vortex, which happened.
The convective vortex. They were all over the place. About a week later, after this is over with, there are some people that have radar loops that are stored now that showed all the different MCVs.
I was looking at it.
And then you're sitting there watching them spin. And that night in Travis,
it looked like a hurricane.
No, it absolutely. And the cell that was out on Cow Creek, northwest of Austin, on Friday night, that resulted in the deaths of 10 to 15 people, including one of our fire chiefs. That thing is 11, 12, 1 o'clock, 2 o'clock on Saturday morning. I'm watching it on this computer screen, and I'm talking to some people in emergency management. The heavy cell's producing 2, 3, 4 inches of rain an hour, and it's sitting doing this. It's just rotating, Lee. It's in the same spot. They say, well, it's moving north. No, it's going to come back at you again. And sure enough, 15, 20 minutes later, the heavy rain would start again. These things were all over the place as a result of this. And days afterwards, I remember one day I'm just sitting here looking. I said, oh, today we don't have an MCV. I'm just sitting there going, thank goodness we don't have an MCV to worry about. But they're just small scale, mesoscale convective vortices that spin up. And this thing started out that way as a tropical. It wasn't mesoscale. It was more of a tropical system off the Gulf. But guess what? It held some of its identity for days over the hill country and over Southwest Texas.
Yeah, I saw the one over San Angelo, and it was crazy. And I guess,
and they had flooding there that was unprecedented in many ways. Water in places where there shouldn't be water. So
again, kind of getting back to that earlier point, not to get too much in the weeds here, but think if I have this correct, that you'll have some rain, it'll come down, the ground gets saturated, and then all of a sudden that rain then evaporates or condenses, and then the heat's released, and all of a sudden you've got this big updraft, and already you have a system that's developed, and it just starts spinning.
And it's sitting there in an environment that is a maritime tropical air mass anyway. Dew points in the low and middle 70s, and
that condensation.
I'm telling you, condensation doesn't. I don't think it contributes that much. Although it's not good, you've already got it there anyway, because you have an MT or maritime tropical air mass. Think humid. You have that in place, and that's what we had in place for days with this event.
So what I tell people is, if you have any of those kind of conditions in place, you should not be near the river, certainly at night, camping there. Right. You should be on guard. I mean, I spent a lot of time on the river and boating, and I'm always looking for cells out there or other signs, which we can talk about. But especially in those situations, like you said on the forecast, I'm not going to go down there if I see that.
Well, And that's great. But again, I'm gonna go back to having that plan. Um, we've got to have a plan. Obviously, the city of Kerrville and for Kirk County, you've got to have a plan. And I think they had a plan. I just don't know how well it was executed, not knocking them. But at the same time, and I'm still hearing people that are fighting us back on this. If you run a camp, if you have campgrounds that you offer for rent for people to go in there with RVs along the river, you, Lee, have a responsibility to have a plan that emergency management folks in that county can look at so that at 3 o'clock in the morning, when the South Fork of the Guadalupe is going up 20 feet in a wave of water, that you can look at, say, okay, what's their plan? And the plan can't be just to sit here and watch the river. That can't be the plan. The plan has got to be, what are you going to do with these humans that you, by the way, you've invited them onto your property. You've made an agreement with them. And part of that agreement probably is that they will be able to leave alive. I've said this all along. There has to be that plan. It has to be shared. It doesn't mean that it's going to be publicly released, but emergency managers ought to have access to it to know what's going on. And then you have to have an alerting system. One of the things that disturbed me most in Kerrville was the fact that once the flood began, pretty close to daybreak is what I'm told, is that some of the firefighters who were basically out on ground zero at that point, and they couldn't do much there except hear people scream going downstream. And one of the firefighters got on the radio to one of the dispatchers and said, we need to set off the alert system. And I don't know if it's I don't know what alert system they have, but the radio transmission clearly has the dispatcher saying, we don't have permission to set off the alert system. To me, that just that killed me. I can tell you, I've been in cases, emergency management, where they've taken my word and we need to alert people. That should never have happened with what happened in Kerrville. They need to be able to, these systems need to be robust. They need to be activated in a moment's notice. When you have someone in authority and a firefighter looking out across the river where there are people washing downstream, I would say that's a pretty good authority to be able to make that call. And for a dispatcher, law enforcement dispatcher, not to have that ability is unforgivable.
I think another thing to keep in mind is that, again, when you have these conditions in place and anything, any kind of disturbance, a cap, whatever it is, very little wind, whatever it is, can set it off. People also don't, and even sometimes without that, when you just have a supercell, people in this part of the country don't understand it can be just fine right here, or maybe you got a little bit of rain, just 10 miles upstream, 25 miles.
Right.
Like you said, you're getting your 4 to 8 inches and it's coming.
And it's going to go. And that's why people, not only, Lee, you say they need to understand meteorology, they better understand geography about where they live and where they stay. I mean, that is so important. We've dealt with this in the past in our coastal areas, Lee, with people that live 4 or 5 miles from the coast having no idea what the sea level is, how far above sea level they are in their property. I think we've learned a lot through the years with that. More and more people know. You've got to know where you are. Are you in a floodplain? Are you in these FEMA floodplains? And by the way, it's easy to tell nowadays. FEMA has a great website where you can do that. Look at floodplains. But you've got to know that. You've got to know where you are, and then you got to know what to do when the getting gets bad. In Kerrville's case, I applaud what I think we're seeing at this point. I don't have much use in 2025 for siren systems, Lee. This is something that's been used for tornado, especially in Tornado Alley and areas like that. And nowadays it's what? If you go up into Kansas, well, you have to think about that siren for a second. Is this the day when they tested at noon? Is that sort of wail on that siren? And then, was that a tornado wail? Is that this way? Is that a volunteer firefighter wail on that siren? This creates confusion. And another thing too, Lee, with that, the misconception has always been, well, we got hit by a tornado here, and I was in my house and I didn't hear the siren. Guess what? You're not going to hear the siren in your house. And so I don't necessarily buy the siren thing for most weather things, but I'll tell you what I do buy it for, Lee, and that is to put it, well, to put sirens along the rivers, because in this case that would serve a purpose. If you walk outside and you realize that river over there you're looking at that's 30 feet down there is rising and you hear sirens going on, that tells you something. You better go get more information. I'm thinking that the installation of sirens, I think that's something they're proposing for Clark County and in that area now. And I hope they succeed with that, because I think that'll make.
Looked at it before, and I think it was cost prohibitive. And I think in particular case of one of the camps, I'm not going to mention the name, but the electricity went out. So yeah, but you got to do it the right way. But I totally
agree. And I understand what I'm saying here. I don't mean to shock you, but the bottom line is 130 deaths enough to buy a siren? Is that the cost? I think that's the way we have to look at it now. We have to make these decisions. I believe that our government could more wisely spend money sometimes. And I think this is a wise way to spend money and make that investment for Kirk County and for the city of Kerrville.
So you mentioned a couple of things in that, Troy. One of them about knowing your area, and when you look at the South Fork, in this case, the Guadalupe, it's a really small watershed. It's got a higher gradient, or a larger gradient, and so if
the water comes down faster,
it's going to come down fast. Exactly, and you need to know that. What though? Let's say you've done that and all that. What resources can people look at today? Like, as the National Weather Service, I look at you and the National Weather Service. There's a forecast discussion on there. What do you recommend that they look at? Obviously, there's a gazillion weather apps. What can they do to, both prepare themselves ahead of time, but also, if something starts to change and it looks like things could get dangerous?
Well, one thing that I'm going to broaden it out for a second with the topic we just talked about. Folks, know what river basin you're in too, because there are only a certain amount of river basins that run from Brownsville to Beaumont. Start out Sabine River there, and you go to the Rio Grande. There are about a number of river basins. They're very unique, and basically those river basins are capture for those rainfall amounts. And then you get into these smaller areas like the South Fork of the Guadalupe, like you mentioned. It's even a smaller part of that river basin. So everyone, one of the most interesting things is, you ever get a chance, go look up at Williamson County up north of Austin. Most people think, well, that water flows into the Colorado. No, a lot of it goes into the Brazos to the east. Yeah, right. There's a separation in Williamson County, separates the Colorado from the Brazos watershed. And so, know where you sit with that, know your elevation of where you live. And so if they tell you the water is going to rise at 20 feet and that river is starting to rise now and you're 10 feet above bank level, you got to get the heck out of there. You've just got to know that. The forecast discussions, the things the National Weather, I think the Weather Service is great. They try to do what they can do, but it's not everyone is necessarily listening. I will also tell you this, Lee, and should have mentioned it before now. We glossed over this. We've mentioned it many times since we started talking, but this is the 4th of July. It's a federal holiday, and it's the middle of the night. Another thing with the Kerrville event, and also with the Austin event the following night up on Cow Creek. These are all things that these are some of the things that affect all that. Most people did what in Kerrville that night, Lee? They went to bed that night assuming, I think there'll be some thunderstorms tomorrow. I heard there's a flash flood watch. Hopefully they did. And they went to bed thinking everything would be fine in the morning, and it wasn't.
Is there a reason why a lot of these happen at night, or seem to happen? Is it just because the heat build up during the day and then that energy is released once air starts cooling at night?
With tropical systems sometimes, and remnants of tropical systems, and I think particularly in this case, the nighttime hours, particularly with a system, if it made landfall on the Texas coast, moved up across Austin, where we would watch as that system dissipates, Lee, we would primarily watch it at night, because during the day, because of daytime heating, the precipitation shield is pretty wide. At night, the precipitation core pulls into the old center, wherever that is, and you get these rains. A lot of people remember the floods of the late 70s, I think, on the Guadalupe into Canyon
Oh,
Lake.
I remember that. Yeah.
And that was a tropical system that produced 30, 40 inches of rain overnight.
78, we got 30 inches of rain.
Yep.
Yeah.
Core rains, small area. But guess what? That small area was in a watershed, a creek watershed.
What causes it to pull in that shield?
It just, because you have daytime heating is now out of the picture, and it tends to pull into the center of it. That's what where it relies upon, and where those core rains tend to develop. There are a lot of reasons, and frankly, I'm probably not stating as best I can scientifically, but those core rains tend to, at night, with remnant tropical systems. Now, if the Sierra Madres destroy a system, I'm just telling you, Curveball system wasn't necessarily the same, but you did have nighttime events with this. But with tropical systems make landfall, watch them at night. The core rains close to the center of circulation as it dissipates.
So here's perhaps the most contentious question I could ask you for our audience here. Okay. Please define, what does it mean when you give a percentage chance of rain? And also maybe you can also, when they say, for this is the forecast, what's the coverage of that?
Well, it's one of the most misunderstood things in weather forecasting, essentially. The way the real world is right now, Lee, if you see a forecast with an isolated or 10% chance of rain, or 20 into that's widely scattered, or 30% or higher into 50% that's more scattered. If you see a 10 to 20% chance of rain, what are most people going to do? They're going to carry their umbrella. I call it an umbrella quotient, in a sense. You get up to 30%, some people they may say, well, Troy said it was a 30% chance, and Troy ain't that good at what he does, so I'm going to carry the umbrella. I got it. Okay. But you then get up into the 40, 50%, 50%, 60% is more scattered to numerous. And then when you get above 60 to 70%, it's basically what I like to refer to as an unqualified. In the forecast, a lot of times it's just showers and thunderstorms likely, or showers and thunderstorms, period. So I'm getting away from your question, but you're not going to let me off completely. What does this mean? Here's what it doesn't mean, and this is so important for people to realize. Let's say that notice forecasts are divided into segments: today, tonight, tomorrow, Thursday night, Friday night. They're divided basically into 12-hour periods, and they assign those probabilities for those periods. What it doesn't mean is that 20% of your area will be covered in rain. It does not mean that. It doesn't. It also does not mean that 20% of the time it will be rain. Does not absolutely mean that. What it means is this: if I'm sitting in Austin and I look at a forecast from New Braunfels for Travis County, and it says 20%, and it's for today, it means from 6:01 a.m. this morning until 5:59 this evening, that if I stand anywhere in Travis County, it's a purely statistical probability, a 20% chance I will get a raindrop. That's what it means.
At any
given
point.
At any given point. It does not mean coverage. It does not mean time.
Which means that it could be none of that area gets any rain.
Well, think about it. All of Travis County, a 20% chance. How much the area is going to get it? Not that much.
Yeah.
I mean, we try not to take the percentage as we know it and try to apply it to aerial coverage, because that's not what it means. But, people tell me, well, it 20%ed on me today. And I said, well, that's fine, but I guarantee you not many people around you probably got any.
Yeah.
In a sense. There's different things that go into that. The meteorologists probably don't think about that much, because we sort of know how it works nowadays. But most importantly, what it doesn't mean, it's just purely a statistical probability that you get rain at any given point. And by the way, at 7 o'clock tonight, you have to look at the tonight forecast and see what it says.
But when they say a forecast tonight, is there a defined area? And let's use the Austin metro area as an example. Yeah. Does that cover 50-mile radius, or
it depends? It depends on the forecast you're watching. All of our TV stations have about the same coverage area, but they would apply it to all their coverage area, which normally is included in the past. I'm looking at my map: Mason, Llano, Gillespie, Blanco, Burnett, Williamson, Travis, Hayes, Bastrop, Caldwell, and Lee counties, and also Milam County off to the northeast. That's normally sort of the forecast area for most of our TV stations. So that would mean a 20% chance for all of those.
Okay.
Weather Service prepares a point forecast, which you can get online, and that's the forecast for that point. But they also prepare what we call a zone forecast, which is per county.
How can you access those, the point forecast?
The point forecast, I'll have to share that with you. It's available on there. It's available online. I'll share that link with you. It's freely available for anyone to see, and you can put it down to a point. And what they do through a process that we call grids is the Weather Service putting their forecast together. It'll go and research that grid where you are, and then query what all the parameters are, and you would be hard pressed, I think, Lee, if you've never seen these before, to want more things. For that point, for 7 o'clock tonight, they list everything from temperature, dew point, heat index, wind speed, wind direction, probability of rain, how much rain will fall. All that's part of the grid process that the Weather Service uses. And you can go pick a point out. And that's what the Weather Service, they have the availability for anyone to do that. It's a little tough to find, but it's there.
That's a good lead in to another big topic. And I would just like to hear your thoughts. I remember from your course, and again, correct me if I'm wrong, but we're pretty good at forecasting within about 3 or 4 days, a macro level, what's going to happen. Outside of that, it's much tougher. How much of that, both within that period, but even outside it, we have all these computer models now. And from what I've seen, they can be really sketchy. I prefer a human forecaster. I know you look at models. Can you talk about how much forecasting is done by the models now, how good they are versus ones that are curated or maybe even done just by humans, and where we are in that as of 2025?
And chances are, by the way, the National Weather Service cannot, by law, have an app. It's a long story, but they can't have it. But if you're going to an app there's an exception now, which I'll share with you so you can share it with your viewers and listeners. There is one app out there now that someone in the Weather Service on his own has built, and it's using the grids. So the Weather Service can't have an app, but guess what? He has built one personally. It's across the United States, and it will give you the same sort of thing. So, by the way, it shows our age a little bit. I think my age, anyway. I don't remember when you were in class, but I would say the 3 to 4 days now we can do a pretty good 5, 6, 7 days. 7 days, I'm a little worried. When you get out there that far. And largely, the National Weather Service, up to about 4 or 5 days, relies more heavily on their human research of the models and coming up with something on their own. Whereas when you get out to days 6 and 7, especially, they increasingly let the models run that. Our model of choice here in the U.S. and owned by the U.S. is something we call the GFS model. And that model is, there's also the European model. You've heard about all the different models that are out there, but the GFS model, you know what, I'm incorrect. I'm going to wind back a little bit. GFS model is our U.S. model, but we have something now called the National Blend of Models, NBM. And what it does is it goes in and takes a little bit of the European, takes a little bit of the GFS, probably a whole bunch of the GFS, and then also models NAM, some of the models that are still out there. And I'm not sure it takes much of the NAM because NAM is more of a shorter range model. But we have a Canadian model that's available that we can see. And it takes a little bit of all that, probably heavily weighed more toward the GFS. The 5, 6, or 6 and 7 day forecast is largely governed by the NBM, by the National Blend of Models. The National Weather Service uses. That's correction. They're not necessarily relying exclusively on GFS. That is our model here in the U.S., but there are times that it's wrong. The National Blend of Models is their way of trying to blend it together, blend everything together. My question is, and I've asked this before, and sometimes I think people look at me like I have 20 horns growing out of my head. But my question is, shouldn't human beings be actually doing the national blend of models? In a sense, isn't that forecasting? But they're letting the NBM run more of the 6 and 7 day, the latter part of the 7 day forecast, to answer your question.
Okay. Yeah, it just seems like, and you've told me this before, that, there's certain, when you get certain conditions, you're very confident what's going to happen. You talked earlier about, high pressure dome comes
Right,
in and summer, and chance of a, you know, major flooding event is almost
right,
nil, right? So
right.
we're really good at that. But then when you like the tropical thing, if you're going to get a big flood, maybe you will sometimes, maybe you won't. It also seems like in the winter, that can happen as well. And of course,
Oh,
we had
yeah,
that snowmageddon thing, but also sometimes you have these polar blasts come in, but it seems like it's hard to know exactly where it's going to go, how cold it's going to get. And, even in Texas, you can get in trouble if you're in the
yeah,
outdoors. And
yeah,
I've even noticed something I wanted to ask you. We've had this happen a few times in recent years where, there's no frozen precip forecast, but it gets in the high 30s and then we start getting some wet precip. And it seems like that comes down and that cools the air right near the bottom. And all of a sudden you start getting a little snow.
right. And part of that is the fact that precipitation type in the winter at 30 degrees north latitude is incredibly hard to predict, Lee.
Mm.
And that's where we are. It's not hard to predict winter precipitation in Kansas City. It's not. I mean, and in Bismarck, it's not that, but at 30 degrees north,
Because
we're
we're right on the borderline. Is that
well, we're
why?
not on the
Anybody?
borderline. We're kind of south of it in a sense, where in order to get snow, you've got to have pretty much a complete atmospheric column that's below freezing, and that's very unusual around here. Lee, if you remember the day on the Sunday on Valentine's Day on February 14th, 2021,
Yeah.
remember it was in the 20s and it was raining. We were getting
Yes,
freezing rain.
I
And
remember
everybody's
that.
asking, what's going on here? Well, colder air was coming in, but what was happening, Lee, there was a place up in the atmosphere where there was a layer of above freezing temperatures. And that was melting to rain. Rain fell, super cool, hit the ground as freezing rain. By the way, what'd you see later in the day, Sunday? It turned to ice pellets. That means
Yep.
raindrops are now
This is
freezing. So it's
exactly
got
what
enough
I'm
to read.
talking about.
And
Yes.
then we got into evening and what? It turned to snow. What happened to the above freezing layer of air? It was wiped out. And
Just
that's
because
what
of all
turned it
that
to
cold
snow.
stuff that came down and warmed it up.
Snow began to reach the
Cooled it
ground.
off.
Yep.
Yeah, that's
So,
exactly when
yep.
I see the temperature in the mid upper 30s and we start getting some precip, I'm always like, wow,
Yeah.
this could go either way. I was at the airport once a few years ago, nothing to forecast, and all of a sudden we started having big
Yeah.
snowflakes.
Yeah.
Got
And there was
snow.
a case here in Austin a number of winters ago. I was at CBS Austin at the time. And I don't know if I've ever been more frustrated. The models, and by the way, let me pull back to the models one more second here. A model that's good today, Lee, in its performance on a certain weather pattern may totally suck tomorrow. I'm just telling you, it can be so bad. The same model.
Yeah.
And what I'm trying to say is all models have certain biases. And we know this. There's actually was a website at Weather Service headquarters where everyone could see it, where Weather Service in Washington, amazing job. They had a total page of lists. This model, what biases it has. Guess what? Um, you might see in a model that the bias is it doesn't predict snow well around Lake Tahoe. I'm serious.
Yeah.
The forecasters in Reno would notice that and they'd submit that and they would check that bias. And what's difficult around here with snow at 30 degrees north latitude is models have a very difficult time judging the depth of the sub-freezing air.
That's what I meant by borderline here.
Yeah,
It can
yeah.
kind of go
And
either way. Yeah.
if you're a couple of years ago at KI, I'm just going to tell that story. 3 days, 4 days in advance, Lee, snow. And by the way, this is when weathercasters, Jim Spencer and all of us back in those days, we're sitting here going, "Oh no, I'm not about." And it came out and said 2 or 3 inches of snow 5 days from now. No, I remember saying I ain't going with that. I don't care, have to hedge it, but no way am I going to do this. it continued in the models to day 4, then to day 3 ahead of time, and day 2. And so by this time, I won't use what I want to use, but basically you have to, it's time to, you have to make a decision. I'll leave it at that. You have to make a decision. And so a day out, we talk.
Fish or cut bait.
Yeah, exactly. I like that one better than the one I was about to bring forth into the world and get us off the air. But we decide to go with the snow. We begin to talk about accumulations, and the models are good and everything else. And finally, we get into the day, and sure enough, the temperatures are in mid to upper 20s. So you're sitting there. What are we thinking on the ground, Lee? It's freezing. It's got to snow.
Yeah.
I'm sitting at the KI Studios on Metric Boulevard in Austin, Texas at about 4 to 5 in the afternoon when the precipitation started. It's 27. It starts pouring down rain. And by the way, it was coming down so hard, you'd say, well, that would freeze. Well, not necessarily. Not when the gutters are full. It was raining that hard.
Yeah.
And so it was forming in trees, and power lines were starting to pick up icing. But frankly, the water was coming down too quick. And it was at that point that I filled out an application to pump gas at a gas station, because I figured that was where I needed to be. That was where I could really put my talents to work, because this wasn't working and people were screaming at it. There were angry people. And we sit there, and we don't have necessarily real-time sensing tools to do this. We only had weather balloons, and that's become a big issue lately. We here in the Southern Plains, we do not have the upper air balloons we used to have. They're been shifted on their time because of the government shutdown. I'm telling you, this is going to be an issue. It's going to show up in a major weather event at some point, and that's going to be the problem, is that the government shutdown required that balloons be shifted and not launched to certain places. That means we don't have that data. But anyway, they're normally at about 6 a.m., 6 p.m. Well, it was 5 o'clock in the afternoon. We don't have the balloon yet. And we began to look, and the only thing we knew, Lee, was if it's falling as rain out there now, that ain't freezing all the way up. It's not freezing all the way up. And believe it or not, at the time, controller friends out at Austin Bergstrom International Airport confirmed to me they had talked to pilots and said there was an above freezing layer between 5,000 and 6,000 feet. And by the way, what happened 4 hours later? That layer chilled.
Yeah.
And then the snow started. But people got to understand, just because it's 26, 27 on the ground, be careful at 30 degrees north latitude about what we call P-type. That's what we call it, P-type. Winter P-type is one of the most difficult decisions in Austin, Texas, during the winter months. Troy, this should be easy for you. Call it sleet, snow, hail, or freezing rain, not hail, but freezing rain. You should know what it's going to do. I wish we did. P-type in the winter is incredibly difficult at 30 degrees north in the Austin, Central Texas area.
Well, just before we wrap up here, and I wanted to ask you a couple last questions, but you mentioned the wintertime, the Valentine's of 2021, that whole 10-day. That seems like an extreme event, but you go back, and particularly a little farther north here in the Dallas metro area, I remember in the early 80s, they had some long cold events, whatever, but we didn't get it with big precipitation at the same time, or if you got the big freezing precip, it only lasted, 2 or 3 days. That thing went on for 10 days. Did you see that coming? How unusual was that? And, is that something that just nobody, that's a 500-year event type of thing, or no, that wasn't that unusual?
It was a major event. Part of it, the fact that it was as bad as it was brought on by us humans, i.e. the electrical grid. And the fact that we're not keeping up with things, that's not meteorology. And you can blame weather all day long, but the bottom line is we weren't prepared in the state of Texas.
Oh yeah, that's a whole nother discussion.
It is. The week ahead of time was interesting for me because remember, I wasn't in a classroom teaching. I was teaching on, on Zoom. Yeah. And so I was here at the home, and what most people didn't know is the week before that weather event, I came down with COVID. I was working in emergency management, and we were having to be tested once a week for COVID through UT because we had access to places and they were being really careful about it. And so I came down with COVID the week before. but I'll always remember that the models were unusually consistent across the board. And at first they were saying, well, it'll be in the teens. It'll be in the teens and 20s and maybe precipitation. And I kind of looked at it and said, oh, okay. And we just talked about colder weather's on the way. And there was a shift in the upper air pattern. It was going to bring air down from the Arctic. We saw that. So we bought it. Well, the next day, guess what? It said, well, it's going to be closer to 10. And we're sitting there going, and they're saying probably more of a winter storm situation. This is like the two. And by the way, if you remember in the week ahead, we were getting freezing rain that week.
Oh, yes.
We had ice on trees much of that week. Oh, yeah.
I was at the office when that started.
Yep. Yeah. And so we were already getting this, and we were looking to the weekend. And I always remember on Wednesday, Thursday, talking to the Weather Service, and they said, this is going to be bad. I mean, everything, the discussions were leaning toward a major event for Texas. You have cold Arctic air coming in, very deep cold Arctic air, and you have a major disturbance going by in the atmosphere on top of that, a low pressure disturbance. So we slowly
when we get snow you get that really cold air, and it's usually from the Pacific, right? Because that air is
little cooler. that really cold air is coming at us from western and central Canada and the eastern Alaska.
But the moisture when we get snow usually comes from the Pacific. Is that right?
Nope, not really. I mean, to some degree, the Pacific system will bring some in, but where's it bringing it in, Lee? It's bringing it in high where the temperatures are lower. What's the moisture holding capability of that air? It's not very much. Around here, rain gauges, if you say, well, in this event or that event, and that brings up the topic. We'll get off course for a second. We're going to run over there for a second. Squirrel, I'm going to run over there. Is that a lot of people think, well, Pacific hurricanes, the one where moisture survives 2 trips over the Sierra Madre of northern Mexico, that they produce a lot of heavy rain from Pacific moisture in Texas. They do produce heavy rain at times in Texas, but it's not Pacific moisture. The moisture up there is rarely limited because the air is very cold. It does act to seed the precipitation down below. But I'm going to tell you, you put a rain gauge anywhere in the hill country around here, I'll tell you that moisture that you're getting that rain gauge as a result of precipitation is Gulf moisture.
Okay. So same in the winter.
Even if it's snow, even in winter, it's going to be Gulf moisture. Now, it may be assisted by an upper level disturbance, upper level.
That makes sense.
It can't hold much moisture because it's very cold up there.
Yeah. Okay.
And this just comes in, and of course, the cold air comes into the Arctic. It's going to be dry, but you'll begin to usher in Gulf moisture. It's colder the air is. Remember, warm, moist air, you may be very chilly down here, but it's still going to ride in somewhere on top of this.
Yeah.
And if you get that at sufficient depths, that's when you crystallize and it falls to the ground as crystals.
Yeah, because you get that wedge, right? Yeah. And so it's scale
And then
up.
look out for that 1,000-foot depth of 35, 38 degree temperatures aloft, because it will screw up your forecast in the winter. But again, just keep in mind, P-type, very difficult around here, 30 degrees north latitude. Go further north, it's not that big of an issue. P-type is not.
I know that was really inconvenient for a lot of people. And then, of course, we had that follow-up ice storm a couple of years later.
Your question, though, going back, yes, we saw it coming. And I keep on my computer here an email that I wrote on Friday, and I looked at it, and I used the word historic. And I forget, I used the word historic winter storm that we have not seen in a long time. And I sat here for 15 minutes before I would hit the button on that. I just sat here, and this is what everybody's saying. I'm sitting here going, I don't know that I want to be tied to this, but I finally did. And the wording, even on Saturday, even got more. I mean, they were saying catastrophic winter weather event for Texas. And I'm not sure, and I use that word, but I use scary words in that email. And I always remember I've got it set aside on a place on the computer where I can look at that. We saw that one coming, but did we see single-digit temperatures? Not the previous Wednesday and Tuesday, but we did see single-digit temperatures in the forecast by Friday and Saturday.
I decided to have fun with it since everything was chaos. I built an igloo.
Yeah.
And that was a lot of fun, a lot of work.
Yeah.
So I figured we probably wouldn't see that again. Well, hey, let's just finish up, Troy.
And then one thing too, that you keep in mind is that, and this goes to us, Lee and Troy, being prepared, that winter storm destroyed this house that I'm in right now.
Wow.
Because of this was an addition and plumbing was put in up here. We thought we had enough insulation. It wasn't. And those pipes burst up there. This, where I am now, my house is about we call it about $160,000 remodel that I got after that because pipes busted in these ceilings up here. I'll tell you, Lee, that winter weather event, less the fact that many of us didn't have power. I've got a generator out here now because of it. But I'm just telling you, it brought new awareness that those events may not occur that often, but they will occur. And
I have a series of steps I do, and being prepared. I was fairly prepared out.
I will go into our next winter weather event that's anywhere close to that. A little more drip into the pipes. I did not turn the pipe in this bathroom on. That's what resulted in the $160,000 loss. So we've got to be more aware. That's part of your plan.
Yeah, and I cut my mains off.
Yeah, absolutely.
I fill the bathtub, and anyway. Well, hey, if someone is planning a trip, let's say, and it could be Texas or anywhere, but and they're going to spend significant time in the outdoors, and let's just say, I know now we have, internet service, it's almost ubiquitous, but let's say you don't have it, whatever. What are some things that they can do just on personal observation? So I know one of them in your class, you talk about Bayes ballot law.
Right. Bayes ballot law is pretty simple thing when it comes. It's a pressure law in a sense where in Texas, if you will stand with your back to the wind, and there are some minor changes you have to make because of Coriolis force and other things, but generally you stand with your back to the wind. Don't have a weather instrument on you, Lee. You ain't got nothing. Stand with your back to the wind. If you hold your left, and again, it's going to look screwy, but if I hold my left hand out, I will point toward lower pressure, and my right hand will point toward higher pressure.
Yeah.
And so that's what Bayes ballot.
If there's inclement weather, it's going to be coming from your left.
Right. It would be probably because of that lower pressure area. And once the cold front passes, what happens to the wind, Lee? It shifts. So I would turn back around and you would do the same thing. Put the wind, hit you in the middle of the back. To your left is lower pressure. To your right is higher pressure. It's not particularly. It's not something that I can tell you. Well, because I looked at the Bayes ballot law just now, and that means it's going to be sunny next Thursday. That doesn't work that way. It just basically is if you're out and you're hiking or anything like this, camping.
I've used it in the mountains before, and I knew a storm was coming in the Sierras.
Yeah, and being in the mountains sometimes can be tricky because you get localized wind flows.
Yeah.
But
no, this was a big wind sustained over a long period of time. And I was like, no, there's something coming in. And sure enough. But what about another thing that I kind of tell people is be on the lookout for, obviously you can see thunderheads building, but also even if let's say you're in a canyon or something, if you see cumulus clouds, right? That tells you there's some severe disturbance, right? There's a thunderhead.
Right. And cumulus clouds are given that name that the root goes back to the mammary gland or the pouch-like appearance to clouds. And we've all seen them before. People freak. People freak.
They look like cotton balls, right?
Well, they look like, I've had people say there are 20 tornadoes off the Northwest. I see them. What the cumulus cloud happens to be is a sign of extreme turbulence. And it does not mean something's coming to get you necessarily. Here's the way I look at a cumulus cloud. If I see one over here, I want to be looking at the radar, and I really want to be querying that storm. I want to see, because something is producing that type of turbulence. The greatest people at danger from cumulus clouds are airplane pilots. I will tell you that we've had more than a few cases where this is why we tell you if you're an airplane pilot, avoid thunderstorms, 20-mile berth. That's sort of a standard rule. We've had planes which have been dismantled in cumulus clouds. The turbulence tears the plane apart and dumps it to the ground. So it's a sign of extreme turbulence. Does it necessarily mean the storm is severe? Large hail damage and wind, not necessarily, but it definitely tells you something about the structure of the thunderstorm that you ought to pay attention to. So if you're camping or something like that, or even at night, lightning lighting up the sky and you see it, I would get over and use a radar app or something just to look at that storm and see which way it's coming or which way it's going. I would at least grow curious that way. It doesn't mean you got to dig a hole in the ground immediately.
And then lastly, that old sailor's adage, red skies at night. I don't know if you go with that, sailor's delight, red skies
Yeah.
in morning, sailor's
I've
warning.
got somewhere back here in all this stuff. I've got a book that, as I graduated Texas A&M, that one of the Met people gave me up there, and it was the old sayings. It's a great book. I wish I could put my
I would
hands on it. I
love to
can't.
see that.
Yeah, and it's just things. There have actually been a couple of books that have been written since. But there's some truth to that. Think about the when we see the halos, solar lunar halos that you will occasionally see, and of course the talk is that rain's on the way. Well, is there any truth to it? Well, guess what? The first thing you'll see with an approaching storm is high level moisture.
Yeah.
And all that
Clouds,
halo
right?
is a
Yeah.
solar effect through cirrus clouds. So your
Yeah.
cirrus clouds will precede a storm system usually.
The
So
horse
does it?
clouds.
But does it always mean no? But
Yeah.
there's some truth to it to some degree. I recommend that if you're gonna, those are fun to look at, and there are a lot of great places to go on the internet. Rely on the National Weather Service. Everyone needs to have a NOAA weather radio. It's the cheapest thing you can ever get. 30, 40 bucks, the cheapest model that'll alarm you for your location in case of a warning. Have that. The Weather Service website is okay. I am going to plug, if you don't mind, this website that my good friend who's at the National Weather Service in Corpus Christi has put together. I strongly recommend it. He has a buy-up. There's a certain buy-up that you get more data on it, but it's called Everything WX. And you and I both know that WX stands for weather. It's an abbreviation, but it's called Everything WX. And he has this great app. And you know what it does, Lee? It queries all of the grid data from the weather. It's a weather service forecast. There's no one else involved. But here's the key. I'll guarantee you, Lee, in most cases, if you're on an app on your phone, you're looking at model data only. No human being, chances are, on any other app is looking at that forecast. The Everything WX app is a weather service. You have people 24 hours a day looking at that forecast and updating it. And that's why I strongly recommend Corey's website, not website, but app, Everything WX. I don't make any money off of it. He has an upsell in there, but you can get it without doing the upsell and get your forecast, not only for the point where you are, it's using that grid, but it also anywhere you travel. And also you can be alerted to severe weather by telling it what type of warnings you get if you allow that app to utilize your GPS chip in the phone.
I'll put that out there for my audience. And
yeah.
Also, Troy, for people who are listening to this who happen to be in Central Texas, can you tell us your website again and any other resources that you provide?
And mine is I don't know how I ever came up with this, but it's Troy Kimmel Weather, TroyKimmel Weather, WEATHER.com. And I do a forecast. That forecast there is targeted for the I-35 corridor and also a little bit of the US 79 corridor up in Williamson County. So it's kind of focused for this area. I try to keep it updated all the time. Is there any severe weather information there? No, except if we have a severe thunderstorm chance, it'll be in the forecast. But it's just a general forecast for the Austin, South Central Texas area.
No, I appreciate that. And lastly, I'll say that, I think like everything in our society, we tend towards sensationalism, but I think you strike a really good balance between, as you mentioned earlier on that severe winter storm we had, of like, I don't want to unnecessarily alarm people, but if something's really significant, I'm going to tell them. Yeah. And so thank you again for all your years of service and providing that information to everyone.
And so much nowadays, and I urge people when they're watching TV, when they're watching an app or watching streaming video from whether, I don't care, I'm not going to mention the national network, but folks, as I close today, one of my favorite things to say, Lee, is I'm hoping at some point, because we're far away from it right now, but we've got to become a more critical thinking society here in the U.S. We've got to get where and I have no doubt that Lee and Troy could do this, but I wonder about other people around this country. We've got to agree to disagree and be able to have a discussion and maybe meet somewhere in the middle. Please be a critical thinker on what apps you use. Are you seeing the words um, 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 tornado plows down? I hate adjectives like that. Let's just avoid the sensational stuff. It scares people. There's fear of weather that's brought on by this. Let's
Stick to
use
facts.
and
also people see that, and then when there's a real one, they ignore it because
exactly. They said, well, nothing happened,
Yeah.
And so let's all become better critical thinkers, think about things and be willing to sit down and discuss things with people around us and be able to come to maybe not what Troy necessarily wants or what Lee necessarily wants, but something in the middle that we could both be happy with. That's my closing thought for the day.
That is a great closing thought. Well, thank you very much for your time, Troy. This has been great. I really appreciate it. And I know this is going to enlighten people and get them to take the weather a little more seriously for their own benefit. So hope we can do it again sometime. So thanks. Thank you so much.
I enjoyed it, Lee. Thank you.
Thanks for watching. If you want to learn more, then check out our website and please hit the like button and subscribe to this channel. Until next time, see you outside.